the means in Python that we organize our functions, constants, classes, etc., so that we can reuse them. They allow us to separate core language while simultaneously facilitate language growth and expansion. So we have like our namespace that is common to all Python applications when they start, and then we have additional functions, constants, etc., that can be imported as needed, such as math or string or the regular expression or sys package that provide additional function and may provide functions with the same names as are defined elsewhere, like with the math library, which works with real numbers, and the CMath package module that works with complex numbers. And we've used multiple modules in the class so far: math, random, string. But really kind of the power in writing our own programs is when we start writing our own modules. And this allows us to collect code that has similar purposes that we've written, put them all in one file, and reuse them in different settings and applications. So for me, for example, I might have a module that has various image analysis functions in it. I might have a different module where I've written particular statistical analyses that I use, and another module for text processing. And as I mentioned, one of the big purposes of this is to avoid collisions of defined names, such as the square root. So what is a module? A module is really, very simply, a Python file. So a file that, it's a text file that ends with .py, and the way I get access to that module in my current Python program is by importing it. So if I have a module named my module, to get it into, I don't want that colon there to confuse you, so let me get rid of that. I would simply type my module. This loads the whole module into the current program, and I access the pieces of that module through the dot notation that we've been using. So my module dot this function. Importing a module only happens once, and that's because this is an expensive thing. So if I change my module, I have to go through a different process of getting those changes loaded into my current Python program. When I say it only happens once, it only happens once within a current shell or a notebook. Another way that I can import something is from my module, I can import something that's defined in that module. So from my module, import my function. This directly brings my function that was defined in my module into my current working space. I can import with an alias, so I can rename my module. So import my module as mm, and this is done a lot. And there's, for different packages, there's usually kind of standards ways of importing. So for NumPy, NumPy is usually imported as np. Pandas, a package we'll use a lot later, is imported as pd. Sometimes they don't make much sense. So there's a graphing package named Seaborn, and we'll import Seaborn as SNS. I don't know where the SNS comes from. Another way we can import is we can do from my module import asterisk. And you see this is very similar to the from my module import my function. And this just imports everything that's defined in my module into the program. And this isn't really a preferred way of doing this because the opportunity for name collisions increases. All right, so let's see. Let's just kind of illustrate this. If I import math, then I can access the math square root function with math.square root. Here there's a function in the OS module that named get CWD stands for get current working directory. I can do an alias, so here's string as string, dropping the I, and I can access the pieces of it. So here punctuation is a list of punctuation marks the string is aware of, and I can do the from random import star, and then I can directly access the random function, which returns a random number uniformly distributed between 0 and 1. Well, when I import a module, Python creates an object, a module object, and this object has various attributes that are unique to module objects. So it creates a name for the imported module, and this will be stored in a variable that's double underscore name double underscore, and we'll see this double underscore syntax a lot in Python. And there's two choices of what that name will be. It'll either be main if I'm using this module as a script or a program, or double underscore module name. So by module name, it's like, what is the name of the module? So in the example here, my module, the name is going to be double underscore my underscore module. There's usually also a double underscore file double underscore, and this is a variable that gives the path to where that file, that module was defined, and a double underscore doc double underscore, which contains the doc string defined for the module. So just like with functions, if we have a string at the beginning of the function, if we have a string at the beginning of the module, that's interpreted as the doc string for the module. So here, for instance, if we look at the math module, we see the file shows where it's located. So it's located in the optconda lib. The name of the module is math. We're not using this as an executable, so it inherits the name of the module. And then this is the doc string. This module is always available. It provides access to the mathematical functions defined by the C standard, etc. See that this is not a double underscore, so I might have to check on the new use of name. Alright, and we've already seen how to access the pieces of it through the dot notation. We can get help on various functions, etc. So how do we create our own module? All we need to do is create a Python file somewhere in your sys.path. And the sys.path, let's just insert this above. So sys is a module in the standard library, and path is a list of all the directories that Python is going to look for modules when you type an import statement. And so the empty string right here is referencing the current working directory, and then we see these things that are part of the Python distribution. Here we have this special directory in our home directory, .ipython, and this is something that I've added in another module demonstration. So, then lower down in the file. So creating a module. All a module is a file, a text file that ends with .py. And that's our standard way of writing Python programs. We're using these notebooks. The notebooks are kind of an exceptional way of writing programs, and the notebooks are a .ipynb file. They contain a JSON object that defines the notebook, but typically a Python program is going to be in a .py file. So I've created a file, mdcrc.py, and here I've pasted in the contents of the program. So I import the random module. I have some numeric constant defined. I have a list of students, list of teachers, then I have these various functions. And just to kind of show you that this is just a regular text file, we can read it in mdcrc.py and print it out as a string. So that's what a module is, a .py file. See, I've already done this down here. So if we look at what the contents, what the attributes of this mdcrc object are, so it's telling me where the file is located, and then it's creating this help string. So this is the string I have at the beginning. See, this module contains data and functions relative to mdcrc 6521 course, but it has also added this other information. So it's gone through and parsed my file, and it says, okay, here are the functions that are defined. Here are the data that are defined. And this is the file where it's located. Let's change this also. Let's print what the mdcrc name is. And it's mdcrc, so we've dropped the double underscore on the naming part. So if I change my module, how do I get those changes loaded back into my notebook or my shell, my Python shell? So let's change the file. So I'm gonna just use vi to edit mdcrc.py. I'm gonna leave the chaperone number the same. But I'm going to change the teachers to, say, be Tom and Eric. If I come back here to my module, if I do mdcrc.teachers, it's Brian and Keith. Well, what if I try to import it again? So if I import mdcrc, and then I see what mdcrc.teachers is now, it's unchanged. But if I come back here, let's just verify this. If I look at what the contents of my file it clearly is now Brian, Tom, and Eric. Okay, and that's because modules are imported only once. So if I've made changes and I want to get them back into my notebook or my shell, I need to use the import lib modules reload function. So let's just try that here. So let me import lib, and I'll do import lib.reload mdcrc, and now let's see what's in teachers. So now it has my changes. Okay, so what's available in mdcrc? Any of the constants and functions, etc., that I've defined. I can also access any packages that I've imported into mdcrc. So I imported random, so I can import the random module. I access it through the dot notation of mdcrc, so it's not random.randinge, it's mdrc.random.randrange. Kind of funny that keeps giving me the same number, isn't it? Something seems a little fishy there to check into. I have another module that's located in a subdirectory something crazier called something craziest.py. Now if I go to import that, okay, we're gonna take a break here and start up a new video so I can get my notebook synced up.